Okay, the augmented matrix we write down, and we know how to do that. Just write down the coefficients and whatever's in the right hand of the equal sign. We've got a little line here. To the left of that little line, we write down the coefficients. To the right of the line, we write down whatever's on the other side of the equal sign. So that this matrix fully represents this equation. We just have to remember that the x coefficients are in this column, y coefficients here, and the numbers to the right of the equal sign here. Then every operation that we do, every legal operation that we can do, and you know what those operations are, and your book tells you what those operations are. Every legal operation we can do will represent an equivalent system. Okay, so we can look at how I've gone about this. Now, of course, when I wrote this out in front of class, we looked at it in different order because you didn't see the whole process. And we wrote it out in order. But the first thing I have to do is get a 1 here. And then I want to leave that 1 alone. I don't want to do anything that messes up that 1. So I still have it here, but the next thing I want to do is I want to get a 0 here. And after I get a 0 here, I want to get a 1 here. And after I get a 1 here, I want to get a 0 here. Now that's not always possible, but with this system it is. Sometimes in the process things go haywire. And we'll talk, we've got a pretty detailed set of videos on row reduction, so this is really pretty much a review. So I'm not going to go into a lot of detail on that, but I will allude to it. Okay, well, how do we get a 1 here? We've got these equations, we want to get a 1 here. Okay, well, the legal thing I can do is I can divide through this equation by any number I want. If I divide through by 4, I'm going to get 1 here. So, well, I do that. And of course, I've also got to divide the -3 by 4, and the -2 is divided by 4. So there's what I get when I divide this row by 4. And I've indicated that with first row divided by 4. It just says first over 4 means first row divided by 4, and that's what goes here. Okay? Now, how are we going to get a 0 here in the next step? Well, we've got a 5 here. We've got a 1 here. If I take -5 times the first row and add it to the second, I'm going to get a 0 here. Well, that's what we do. We do the second minus 5 times the first. Now, we don't change the first row. We just use a multiple of that row, which we add to the second to get this. So, what? -5 times, okay, here's the second. -5 times the first would give us -5 here. -5 and 5 gives us 0. Then we have 7 here. And -5 times -3/4 gives us plus 15/4. 15/4 and 7, well, 7 is 28/4, so we get 15/4 and 28/4, which is 43/4. And I did, give an admonition, you got to be able to do basic fractions, okay? If you don't know how to do that, well, I did state that you're going to be more likely to get systems that can be solved using whole numbers, if you do it in the obvious way, than systems that are going to involve fractions. But still, fractions can occur. So be prepared for that. Okay, well, anyhow, we have the -3/4 here. Well, I'm sorry. We have the 43/4 here that we get from 5 times this added to this. And then 5 times -1/2 is -5/2. And 19 is 38/2. I'm sorry, -5 times this is plus 5/2 because this is a negative. -5 times -1/2 is plus 5/2. Added to the 38/2 you have in 19 it gives you 5 plus 38/2, 43/2. So that's how we get this. And now in the next step, what are we after? We want a 1 here. Okay. Now you can think about why we want this sequence. 1 here, then 0 here, then 1 here, then 0 here. After you've worked a few, it becomes obvious that that is the way to do it for systems where it's possible to do that. Okay, so how am I going to get a 1 here? Now remember, I don't want to mess with my first row, and there's nothing I could do to my first row that would give me a 1 here that wouldn't mess up my 0 anyhow. multiple of the first row, I could add to the second. And remember, I don't want to mess with this 1, I don't want to mess with this 0. Okay, well, I've got this row. If I multiply this row by the reciprocal of this number, I'm going to get a 1, right? If I multiply by 4 over 43, 4 over 43 times 43 over 4 gives me 1. Numerator and denominator, if you multiply them up, become the same. So I multiply the second row by 4 over 43. Well, 4 over 43 times 43 over 4 does give you 1. You also have to do 4 over 43 times 43 over 2. Well, it turns out that that gives you 2. You can multiply that out and see. So now the second row reads like this. Now what does that row mean? It means no x plus 1y equals 2. Doesn't that tell us that y equals 2? Of course, we already know that that's a solution. You see, there we've already got our y equals 2. And we could actually stop at this point and plug that back into the first equation and find x, but we're going to go one step further. And we're going to eliminate that negative 3/4. Okay, well, pretty easy to do that. You just take negative 3/4 of this row and add to this one. I'm sorry, you take 3/4 of this row and add to this one. You'll have a 3/4 here and a negative 3/4 here. You're going to get 0. So we take 3/4 of the second row and add to the first. Okay, well, 3/4 of 0, of course, is 0. Adding that to 1, we don't hurt the 1. 3/4 of 1 is 3/4. Added to negative 3/4 gives us the 0 that we're looking for. That's why we did this. Okay, and then we also have to, of course, do 3/4 times this added to this. Now, I said, what's 3/4 of 2? And, you know, what I'm saying is people need to review fractions. I'll just say that. Okay, that's going to be 3/2. 3/2 and negative 1/2 is 2/2, which is 1. So we get 1. And now we have a system that reads x plus 0y equals 1 and 0x plus y equals 2. Or you could say 1x and 1y, just write down all the numbers. That thing cross-eyed. I was seeing x equals 2 because I was too close to the board. I knew that wasn't right. Okay, so this says x equals 1, this says y equals 2. There's our solution by row reduction. Now, this video is getting a little long, so we'll go on to the next one and kind of quickly do the inverse matrix.